In this video, I'm going to talk about how you can solve rational equations. A rational equation is an equation that involves one or more fractions. Let's start by reviewing some basic operations with fractions. Pause the video while you attempt to work the questions here. Recall that, in order to add and subtract fractions, we must have a common denominator. For part A, my least common denominator is 35. Note that, if I ask myself what multiplied by 5 gives me 35, and what multiplied by 7 gives me 35, I can give integer answers to both of those questions. To fill in the numerators, I can multiply both the top and bottom of the first fraction by 7, and I can multiply both the top and bottom of the second fraction by 5. This, of course, tells us that 4/5 minus 3/7 is equal to 13 over 35. For part B, my least common denominator will be 8. Note that, when I ask myself what multiplied by 4 gives me 8, and what multiplied by 8 gives me 8, I can give integer answers to both of those questions. To fill in the numerators, I can multiply the top and bottom of the first fraction by 2, and I can multiply the top and bottom of the second fraction by 1. I can now say that 3/4 minus 1/8 is equal to 5/8. For part C, my least common denominator will be 30. To fill in the numerators, I can multiply the top and bottom of the first fraction by 5, and I can multiply the top and bottom of the second fraction by 3. I can then add these fractions together and get 26 over 30. To simplify this further, I can reduce this fraction by dividing both the top and bottom of the fraction by 2. In the next slide, I'm going to give you a rule that says that you can cancel something if it is multiplied by everything else on top and bottom of the fraction. Note that the 2 is multiplied by everything else on both the top and bottom here. So, you should be able to see that I can use this rule to cancel the 2's, and that this problem simplifies to 13 over 15. Now let's look back at those problems and talk about the common denominators. As I said earlier, you can choose a common denominator of 35 for part A because if I ask myself what multiplied by 5 gives me 35, and what multiplied by 7 gives me 35, I can give integer answers to both of those questions. However, as you think about the questions in this section, you might find it helpful to use a different thought process to find the common denominators for your problems. Since 5 and 7 have no factors in common, I can just multiply 5 times 7 to find the least common denominator for part A. For part B, I can note that 4 is equal to 2 times 2, and 8 is equal to 2 times 2 times 2. To find the least common denominator, I'll note that the 4 is missing a factor of 2 that the 8 has. And so I can find the least common denominator for this problem by multiplying 2 times 2 times 2. For part C, I can note that the 6 is missing a factor of 5 that you see in the 10, or I can note that the 10 is missing a factor of 3 that you see in the 6. That means that I can find the least common denominator for part C by multiplying 2 times 3 times 5. As we talk about the remainder of the problems in this section, you may find it helpful to refer back frequently to these examples. In the remainder of this video, I'll use the steps you see here to solve each of the equations I'm going to discuss. Also note the note at the bottom of the page. You will hear me talk about it frequently in this video. Feel free to refer back to this slide as you need to. As I said in blue at the top of the page, I will start the problems in this lesson by making a list of values that x cannot equal. This means that I will find the values of x that make each of the denominators equal 0. Note that, if x equals 0 or 2 for this problem, then one or more of the denominators of the fractions will equal 0. And recall that, as I talked about in my video on graphing rational functions, a fraction that has a denominator equal to 0 will be undefined. So, if I solve this equation and decide that x could equal either 0 or 2, I will change my mind and exclude this answer from the solution set. For the next step in this problem, I will eliminate the fractions. To do this, I will start by factoring the denominators and then multiplying each term of the equation by the least common denominator. Note that I can factor the denominator in the second fraction by factoring out the greatest common factor of 4. To find the least common denominator, I will note that I can break each of the denominators up into their individual factors as you see here. If you think back to the set of examples that I started this lesson with, you should be able to see that I can say that the least common denominator is 20x multiplied by x minus 2. If you thought that the least common denominator was 20 multiplied by x minus 2, I'll talk about why that's wrong in a moment. For my next step, I'm going to multiply each of my terms by this least common denominator. And now I can use the rule that I talked about earlier that says that you can cancel something if whatever you want to cancel is multiplied by everything else on the top and bottom. In the first fraction, you have an x multiplied by everything else on the top and bottom, and so I can cancel those. Essentially, what I'm doing here is reducing the fraction by dividing both the top and bottom by the same thing. In the second fraction, you should be able to see that because 20 is equal to 5 times 4, I have a 4 that is multiplied by everything else on the top and bottom. That means that I can simplify the second part of the equation by dividing both the 20 and 4 by 4. Since I also have an x minus 2 that is multiplied by everything else on the top and bottom, I can simplify the second part of this equation further by dividing both the top and bottom of this fraction by x minus 2. To simplify the third part of this equation, you should be able to see that I have a 5 multiplied by everything else on the top and bottom because 20 is equal to 4 times 5. I can also simplify this part of the equation by noting that I have an x multiplied by everything else on the top and bottom. And that means I can simplify this part by dividing both the top and bottom by x. As I hinted at earlier, many students think that they can leave the factor of x out here and just use 20 multiplied by x minus 2 as the least common denominator. However, you should be able to see that, if you do that, you will not be able to cancel the x in the first part or the x in the third part with anything because you will not have an x multiplied by everything else on the top. That means that I do need to include the x as a factor when I talk about the least common denominator for this problem. I can now simplify what I have left after these cancellations. That gives me the equation you see here, which is an equation that you should know how to solve at this point in the semester. For my third step, I need to substitute this value back into the original problem. It is possible that I have done all my math right, but the answer I got doesn't actually work in the original equation. Since I got an answer of x equals negative 8 in the last slide, I'll start by changing all of my x's in the original equation to negative 8. Next, I'll work with each side of the equation separately and hope that I can get the same answer on both sides of the equation. Since the work I have here shows that both sides of the equation are equal to negative 6 over 40, I can conclude that my answer of x equals negative 8 must be correct. To work this problem, I'll start by finding my excluded values again. As I said earlier, you can do this by finding the values of x that make the denominators equal 0. As you can see here, that tells us that x cannot equal 5 or negative 2 for this problem. For my next step, I'm going to eliminate the fractions by multiplying each term by the least common denominator. To figure out what the least common denominator is, I need to factor the denominators. And now, if you think back to the examples that I started this lesson with, you should be able to see that the least common denominator is x minus 5 multiplied by x plus 2. That means I'll multiply each of my terms by x minus 5 multiplied by x plus 2, like you see here. In the first part of this equation, I have an x minus 5 multiplied by everything else on the top and bottom, and so I can cancel those. In the second part of this equation, I have both an x minus 5 and an x plus 2 multiplied by everything else on the top and bottom, and so I can also cancel those. And in the third part of this equation, I have an x plus 2 multiplied by everything else on both the top and bottom, and so I can simplify this part of the equation by dividing both the top and bottom by x plus 2. That leaves me with the equation you see here. Note that I do need parentheses around the x plus 1 because I need to say that the entire x plus 1 needs to get multiplied by the x minus 5. To solve this equation, I can distribute the x to the terms in the first set of parentheses and multiply out the x plus 1 times x minus 5. And then I can subtract x squared from both sides of the equation and finish solving for x. As you can see here, this gives me x equals 5. Now I need to substitute this answer for x in the original problem and then find out if the two sides are equal to each other. As you can see here, this gives me 0 in the denominators on the left. As I said earlier, the denominator of a fraction can never equal 0, and so I will say that the final answer to this question is no solution. If you would like to make your life easier, you might recall that I said in the first step of this problem that x could not equal 5. That means that I didn't actually need to do the third step here. I can just use the information from the first and second steps to say that the answer to this question will be no solution. Now pause the video while you attempt to work this problem on your own, and make sure that you remember that you can only cancel something if it is multiplied by everything else on the top and bottom. For my first step here, I'll start by making my list of excluded values. You should note that the denominator of the second fraction can never equal 0, but I can make the denominator of the first fraction equal 0 by letting x equal 0, and I can make the denominator of the third fraction equal 0 by letting x equal negative 2. That means that if I come up with an answer of x equals negative 2 or x equals 0, I must exclude that answer from the solution set. For my next step, I will note that none of the denominators here can be factored further, and so my least common denominator for this problem will be 2x multiplied by x plus 2. That means that I need to multiply each of my terms by 2x multiplied by x plus 2. In the first part of this equation, I have an x multiplied by everything else on the top and bottom, and so I can cancel these x's. In the second part of this equation, I have a 2 multiplied by everything else on the top and bottom, and so I can cancel these 2's. In the third part, I can cancel the x plus 2's that are multiplied by everything else on the top and bottom. When they look at this problem, most people think that the least common denominator is either 2x or x plus 2. If you thought that the least common denominator was only 2x, note that you would not be able to cancel anything in the third part of the equation because neither the x nor the 2 would be multiplied by everything else on the top and bottom. If you thought that the least common denominator was only x plus 2, note that you would not be able to cancel anything in the first or second part of the equation because neither the x nor the 2 would be multiplied by everything else on the top and bottom. After I have canceled everything that I can, that leaves me with the equation you see here. I can make that look a little nicer by writing the equation you see here. To multiply out 2 times x plus 4 times x plus 2, I can multiply x plus 4 times x plus 2 and then multiply the answer by 2. In the second part, I can distribute the minus x to the x plus 2. This is going to give me a quadratic equation, and I can solve that using either factoring or the quadratic formula. In order to use either of those, I need to rearrange the equation so that I have a 0 on one side and the rest of the equation on the other side. I chose to solve this equation using factoring, but you would get the same answers if you use the quadratic formula. And finally, I need to check both of these answers, and I will check them separately. I can check x equals 8 by substituting 8 for all the x's in the original equation. As you can see, that gives me 1 on both sides of the equation, and so I know that the answer of x equals 8 must be correct. I can check x equals 2 by substituting 2 for all the x's in the original equation. That gives me 5 halves on both sides of the equation, and so I know that that answer must also be correct. When we solve an equation, we want to find all the values of the variables that make the two sides of the equation equal each other. Since substituting both x equals 8 and x equals 2 in the original problem gave me true equations, you must list both of these solutions if you want your answer to be completely correct. If you enjoyed this video, then please subscribe to our YouTube channel and see all of our products available at algebraforhomeschool.com.